Alrighty, so today we're going to be working with this problem here, problem 50, and it's just asking us to find a whole lot of stuff, and so this is kind of all my work for it. Up here at the top, I just kind of used the information that we were given to draw what they were saying. I'm a more visual person, and so I started there, and we know that the directions of the electric field, magnetic field, and motion of the electron is all shown right there. And then we know that from what was given, we know that the electron has the velocity along the negative y-axis. That's going to be up there. And the direction of the magnetic field is on the negative z-axis, which is there. And then the electric field along the negative x-axis, which is going to be there. And so V cross B is going to give you the electric field. And so that's just going to be some information there. We know that the magnetic force is going to be given by F is equal to Q V cross B. And that's kind of the main thing that this chapter was on. And that's going to be the Lorentz force. So that's how we get that equation there. And so we know that when you do V cross B, it is going to be in the negative x direction. So you use your right hand rule, got that going on here, and it's going to come out. And that's which way our negative x is. So that works out perfectly. And then so for part B, we know that the electric force is opposite of the electric field. So that's going to make it going down the positive axis. Then for part C, we know that from the given data, the velocity is along the y-axis, so it's going to be over here. And the magnetic field is along the z-axis. And so we're given all of that, and so when you do the cross product, same thing with that, V cross B, it's going to be in the same direction as the electric field, which is going to be the negative x direction. And so for part D, we know that the magnitude of the magnetic force on the electron is F of B is equal to E, the magnitude of V, times the magnitude of B. B being the magnetic field, V being the velocity, and E being the charge. And so we're going to need to find the magnitude, which is what I did here, find the magnitude of V, and find the magnitude of B. And so we get those because we are given this V sub z squared. We're given that, and V sub y and V sub x are both going to be 0 because we're only looking at the negative z direction. And so you square that, take the square root, that's going to give you this here. And then the magnitude of the magnetic field, so it's going to be the same thing, except for in this case we're given the y component here. And so when you solve all that, it's going to give you 0.27. That is a mistake here. Excuse that. It's going to be a 7 there. And so that's going to be the magnetic field. And then so we're going to take everything that we just did here and plug it back into this equation up here. So V is equal to ED. I'm sorry, I did it here. We're going to plug all that back in there. When you simplify that, it's going to be written here. You should get that answer. And then for the last part, we are going to, it's going to be a continuation of part D. We need to find the potential difference between the plates, and that can be written as this formula here. And so, which can be simplified to magnitude of V times the magnitude of B times D. And we're given all of those, or we solve for them like we did up here. And then when you plug those in, you should get this number here.